The TCP/IP, or Transmission Control Protocol, Internet Protocol model is the foundation of modern Internet communication, and it's divided into 4 layers, each responsible for specific networking functions. Let's explain each layer and its protocols. The first layer is the application layer. This is the topmost layer where high-level communication occurs between applications. It defines the protocols for communication and data exchange between software applications. It includes HTTP, or Hypertext Transfer Protocol. What does this do? HTTP is used for transferring web pages and resources like images, CSS, and JavaScript over the internet. How does it work? Well, a client or browser sends an HTTP request to a server, and the server responds with an HTTP response containing the requested resource. TLS, or Transport Layer Security. What does TLS do? TLS ensures secure communication over a network by encrypting the data exchanged between clients and servers. TLS operates over HTTP to form HTTPS, encrypting the traffic to protect data integrity and privacy, ensuring that attackers cannot intercept or tamper with the communication. And finally, DNS, or Domain Name System. DNS resolves human-readable domain names like www.example.com to machine-readable IP addresses like 192.168.1.1. So when a user enters a URL, the browser queries the DNS server to translate the domain name into an IP address required to contact the correct server. The second layer is the transport layer, and the transport layer manages end-to-end communication and provides error checking and data flow control. The 2 main protocols are TCP and UDP. TCP, or Transmission Control Protocol, is a reliable, connection-oriented protocol that guarantees delivery of data between devices. TCP ensures reliable data transmission by establishing a connection before transferring data via a handshake, dividing data into segments, and retransmitting any lost segments. It ensures in-order delivery and error correction. And use cases of TCP include web browsing, email, and file transfers, which uses HTTP, SMTP, and FTP. UDP is User Datagram Protocol, and UDP is a connectionless, lightweight protocol without guaranteeing delivery, order, or error correction. So UDP sends packets called datagrams without establishing a connection and does not ensure delivery or order, making it faster but less reliable than TCP. The use cases of UDP include real-time applications like video streaming, gaming, voice over IP, where speed is more important than guaranteed delivery. The third layer is the internet layer. This layer is responsible for routing data across networks using IP addresses to identify devices. It handles packet forwarding and addressing. IP stands for Internet Protocol, and it is responsible for routing packets of data from the source to the destination across multiple networks. Each packet contains source and destination IP addresses. Routers use these IP addresses to direct the packet across the network to the correct destination. There are 2 main IP versions, IPv4, or Internet Protocol version 4, and IPv6, which is Internet Protocol version 6. IPv4 uses 32-bit addresses, which allows for around 4.3 billion unique addresses, for example 192.168.1.1. Due to IPv4 address exhaustion, IPv6 was introduced. It uses 128-bit addresses, allowing for virtually limitless number of unique addresses. You can see a 128-bit IPv6 address on the screen. Layer 4 is the network access layer, or the link layer, and this layer is responsible for the actual transmission of data over the physical network hardware, such as cables, routers, and switches. It includes protocols and hardware standards that define how data is transmitted within the local network. Ethernet is the most widely used technology for wired LAN, or local area networks. It defines how data is transmitted between devices in a wired network using MAC, or Media Access Control addresses. Devices on an Ethernet network communicate by sending frames that contain source and destination MAC addresses along with the data. Ethernet provides physical transmission and error detection at the local network level. Wireless LAN, or Wi-Fi, provides wireless communication using radio waves instead of physical cables. It's used for devices to connect wirelessly to a network. Wireless LAN transmits data over the air between devices using protocols like IEEE 802.11. It operates similarly to Ethernet but without wires, and devices communicate via Wi-Fi access points. Now let's take a look at the overall data flow example of an HTTP request. For the application layer, a user requests a web page, and the browser generates an HTTP request like get/index.html. For the transport layer, the HTTP request is encapsulated in TCP segments, ensuring the data is reliably transmitted. For the internet layer, the TCP segments are encapsulated in IP packets. The packets are routed across the internet using IPv4 or IPv6 addresses. And finally, the network access layer. The IP packets are sent over the local network using Ethernet, which is wired, or Wi-Fi, which is wireless, to the router, which forwards the data to its final destination.